of IET and chair of GSM Association. He was awarded a CBE in 2012 for his contribution to the mobile industry. So let us, with a big round of applause, invite you, sir, please. Either you can come here and then I am just handing over to you. You can have your panel now.
Thank you. So good morning, everybody. It's a great pleasure to be here. Today's sessions are very much about the enablers for 6G, and this first session is very much on NTN, non-terrestrial networks, so showing how the satellite can contribute in this area. So I've got an excellent team of panelists who are going to talk about the enablers for the satellite part of NTN, but clearly spectrum is a very important area, so we're going to cover a little bit on that first. We also, after this session, will clearly see some other subjects covered that are key enablers, particularly around spectrum and standards together. Also later on, semiconductor advancements for 6G readiness. And lastly, how can we drive more of the global cooperation to actually deliver a unified 6G roadmap. And then finishing off with some way forward type sessions. But this session, if I can invite my speakers to the stage, and then I'll ask each of them to introduce themselves. Veena, if you'd be happy to join us here. Veena Rawat is a senior spectrum advisor to the GSM Association and has been involved with radio communications for over 30 years, formerly president of Canada's Communications Research Centre, but as you may realize, she's Indian-born and a very talented lady. If I could also ask Professor Rahim Tafazoli to come and join us here. He's, like myself, a professor at the University of Surrey, but runs something called the 5G and 6G Innovation Centre. Are you happy to sit there, Rahim? And we'll say a bit more about what he's doing research-wise in the area of NTN. We should have also, is Dilip Krishnaswamy in the room? Dilip, yes, I thought I saw you there. He's an executive vice president of CDOT, and is leading some of the advanced 5G and 6G innovation for CDOT. He has a PhD in electrical engineering from the University of Illinois and has held key roles in Intel, Qualcomm, IBM and Geo platforms, and a major patent holder. We should also have in the room Lieutenant Colonel V.S. Villan. Would you please step forward? He's the CTO of Elena Geosystems. He calls himself a technocrat, but has had significant interests and experience in the defense, space and GNSS areas, and has contributed to DRDO, ISRO, and the Indo-Russian GLONASS program. So a lot of strong satellite experience with some military background. We should also have Mr. Ravi Gandhi. Is Mr. Ravi Gandhi in the room? I haven't had the chance to meet him. He's not here yet. And that means... have I missed anybody? And Amitabh. Yes, I saw Amitabh earlier on. Amitabh Matadil, if you could step forward, please. He's a senior vice president for Airtel, here based in India, and working at Bharti Airtel. He's led the devices strategy division and has over 23 years in telecommunications. So will you please welcome the panel here this morning? Now, if I could just start on the far end, sir, if you wouldn't mind doing your 1-minute brief introduction to say who you are and what your interests are in this subject, and we'll work across and then ask Veena to present a couple of slides, a few slides on spectrum. So please, sir.
Hello. Yeah, so I'm with the Center for Development of Telematics. It's the R&D wing for the Department of Telecommunications in India, and our primary goal is ubiquitous coverage going into 6G, and then how we can do that with satellite-based coverage for the country. But then we've come up with configurations that can serve India, but then we've rotated it and it can serve UK as well, for example, and so on. So, we're interested in developing and enabling such technologies with global partnership as well. Thanks.
Right. Hi. My name is Amitabh. I work for Airtel. was hoping I would have one more colleague from an operator here, but I reckon I'm the only one who represents an operator here today. I think from an operator perspective, it's kind of obvious what our interests are, because all the technology that people here do, we are the folks who actually take it to market. And if you look at a country like India, there's real connectivity challenge that we are yet to solve, and we strongly believe that at some point in time, NTN is an imperative rather than a technology item that we actually look at.
Amitabh, as a former operator, I will give you some backup, and I'll describe operator requirements a bit with you in a minute.
Hello. Good morning, everyone. I am Colonel Valen. I bring the technology perspective into this, also the defense perspective. You would have seen that fun slide which was there in the initial time. I'm one of the defense officers who are just able to understand what it is. So I'm here in front of you. We are working into NAVIC technology per se. We have everything that's required in NAVIC technology. When I say NAVIC technology, it's per se different from other GNSS technologies, which are generally MEO-based solutions. Ours is GEO and GSO based with L5 and S-band. Others are all into L-band side only. So ours is a different technology, and we believe that this technology is what will take NTN to its operational goal. If you put, that's what I'll be talking about in future.
And we may need to bring out the different orbits a bit to explain to the audience in a minute. So, Veena?
Good morning. I'm Veena Rawat, and I spent my life in Canada, a good chunk of my life, as the spectrum regulator. I headed up the Communications Research Center, where we did a lot of research, not only in terrestrial communications, but a lot in satellite communications, Canada being a satellite country, a large country, looking for a lot of coverage. My current day job, which I've been doing for last 10, 11 years, after leaving CRC, having 4 years with BlackBerry, if many of you may not remember that phone, but I do very well. And I have been now consulting as a senior spectrum advisor for GSMA, whose presence you have seen not only at P6GA, but also at the IMC. And my day job right now, my thinking, what I think is how to get spectrum for 6G internationally from WRC 27. So that's my day job, to be looking at that. Together with that, WRC also has got some satellite issues, and NTN is, this WRC is actually called Space WRC 27 because of the number of satellite issues, but quite a few of them deal with the mobile connectivity and mobile satellites. So I will be talking about that.
Thanks, Veena. Rahim?
Good morning. I'm Rahim Tafezuri from University of Surrey, Director of ICS, Institute for Communication System, which is the home of 5G, 6G Innovation Center. I've been in mobile research. I don't know how many years it is, but since 2G. And also the first generation of satellite PCN. If you want to know what is the first generation of satellite PCM, is Iridium, Global-Star, and that sort of system. I would like to discuss with you and share with you research challenges as far as NTN is concerned, as well as 6G is concerned, as well as opportunities.
Great. I'm now going to ask Reena to step forward, and we'll present your slides briefly, because having some spectrum background is helpful to understand this subject, and then we'll move into Q&A within the panel. So Reena,
Thank you.
there's the clicker, and they should put the slides
So
up.
I have to look there for the slides, I guess.
They'll give you the slides.
Where? I'm not tall enough to look at there. Okay, anyway, good morning again, and I will start. I missed the Space Summit here the first day, but I heard a lot of development and priority and the importance of the space connectivity for India was presented and discussed, right down from the minister's level, and a very, very good discussion at that Space Summit. I have read the press clippage of that, but I was very pleased to learn about the priority of space. I also know the priority of space with my colleagues. I participate a lot in ITU meetings and with ISRO's participation in just about every meeting, and talking about the satellite connectivity and the importance. So I'm well aware of the importance of the space connectivity to India. As I mentioned, that GSMA also has a very good presence here. We talked in this in the context of the 6G yesterday. The CEO talked about the status of the mobile connectivity in India, and that's in that context he talked about what the coverage gap is, what the usage gap is happening in India, and then one of my colleagues talked about the spectrum needs for 6G. But that was all the discussion about the terrestrial, the 6G on the terrestrial side. But as we have been seeing that there has been lots going on over the last 3-4 years in terms of the satellite connectivity, and why the interest and why this sudden recent interest in the growing development in the satellite connectivity, and that's what I want to focus and see what the spectrum challenges are there. So I guess if I can start with my first slide, I will just have to manage the mics so that I can. Where's the clicker? Oh, where's the clicker? Okay. Go forward? Yeah. Okay, perfect. Okay, so you heard from the keynote yesterday that we have a big usage gap. Globally speaking, GSMA working globally, they collect the global data, and we talked about in a different way, the data was presented to you that, globally there is a 58% people connected. When I say connected, mobile internet connected. So please keep that in mind. I'm not talking, everyone has, mobile phone, but the mobile internet connected. There's a 4% of the world population is not connected from a mobile internet perspective. And then the biggest thing is the highest number is the 38% of the global population is they are living in the coverage, however, they do not connect. And there are many different reasons for not connecting, whether it's affordability or skill sets or everything else, and that's a separate discussion. Now, what does it mean in the context of India? Well, the numbers are, in terms of the coverage gap, it's still 4%. That's okay. But the usage gap for mobile internet is about 50%. So 50% of the population doesn't do mobile internet. That's what it means in terms of India. But again, what I want to focus, because I'm talking about NTN, I'm going to focus more on the coverage gap, because that's what the satellite networks will provide. And the other focus I will do, the coverage gap, you have to not only cover from a mobile internet connectivity perspective, but you also have to cover from the fixed connectivity perspective. And the satellite play a big role both on the mobile connectivity as well as on the satellite fixed connectivity. So my focus will be on the satellite connectivity for mobile. And for that, you have been, I'm sure, very familiar with the term D2D. It's not door-to-door. If you go Google and you get door-to-door, unless you are very precise. So direct-to-device, and there are many different ways of, many different acronyms have popped up since last few years, but I will just use the word direct-to-device. And the device for me means your smartphones connecting directly to the satellite. And that's my focus today, is to really talk about the direct-to-device. And the purpose of the direct-to-device is to address that 4% coverage gap. The number for the coverage gap for India is very similar. The 4% of the population is not connected. Okay. I have to move forward. Okay. So these 58%, translate that into about 46% in India. The people who are connected, who have the mobile internet, they are connected terrestrially. So those people are, they are the ones who are going to be benefiting from the satellite connectivity. You will ask the question, why why we haven't been having this satellite connectivity for, for a long time. Well, this did happen. The satellite operators, way back when, they did try to serve the mobile customers. And I don't know if many of you or some of you may know, in Canada we called it auxiliary terrestrial component of satellite. In Europe we called it complementary ground component of satellite. That was all to provide connectivity to the terminals on ground. But that was not, the number of terminals were not scalable. They were not the mobile phones we are talking about, 4.7 billion subscribers around the world with 58% the population of the world. So now, why is this interest happening globally in the satellite connectivity is because we have the mobile scale. We have these devices, that's what we are talking about. The other reason why we didn't have the satellite connectivity and ATC or CGC was in that, didn't pan out the way we are talking about D2D is at that time the price of the capacity was very, very high. So moving on then, Mike said that I'll talk about the spectrum. WRC-27, as I mentioned earlier, has, notwithstanding the fact that there are a lot of agenda items dealing with satellite, there are 3 agenda items dealing just with mobile satellite. And one of them is dealing specifically with the direct-to-device. And you might hear the people who just talk very quickly about WRC-27 agenda item 1.13. Okay, well, that's the agenda, 1.13 is very commonly known now as the agenda item, a difficult agenda item to come up with an international regulatory framework from AWRC in 2027. But the commercial demands, the commercial development, the technological development does not wait for ITUs, WRCs to run through and have the international frameworks. The interest has been coming through. Before WRC 23, you may know that the Global Star, provided a service to iPhones, the iPhones 14 Plus. It was 2022, and that's one of the reasons for this agenda item. And so the work was going on, and some countries, particularly with large geography, they started their policy formulation, national regulations, such as Canada, because we're a large country there, and we wanted to make sure that the people who have the mobile internet connectivity or who are in the coverage gap at least are served with the satellite connectivity. So Canada came out with their own spectrum rules. US came out, Australia came out, and a number of other countries came out with their rules, and including UK doing consultation and very close to finalizing their policies. That was one side. But nothing happens without standardization. So the 3GPP started work, and I would say the Release 17 became a foundational, I call it a foundational standard for D2D, because they came out with the standards for D2D in the proper bands which are allocated to mobile satellite service in the 1 to 3 gigahertz range. So that standard also helped in moving forward with some of the development of these national regulations and policies. Although the national regulations and policies, when I talk about it, I want to be very clear. I'm talking about D2D in the mobile spectrum. The 3GPP standards came out in the satellite spectrum. So these national policies I talk about are for using the mobile spectrum for satellite connectivity, for direct-to-device, and providing services directly to handset. The other thing I want to point out is to be very clear about this, what is meant by D2D and how the international regulatory framework will be developed. It's written very, very clearly that this direct-to-device we are talking about is for providing supplemental coverage to the mobile coverage which is already there. It is not replacing the mobile coverage. It is just filling the coverage gap, if you want. That's one part. The second part, very clearly, is that it's going to be really connecting directly to the device, directly to your smartphones. No modifications, unmodified devices. And the third thing, which this agenda item points out, is that because this D2D is going to be using the spectrum, mobile service spectrum, that we have to make sure from an international regulatory framework that the terrestrial services, commercial mobile services, in ITU parlance we call it IMT services, are not negatively impacted. Because we are talking, when I talk D2D, another thing I should mention is what we are doing is when I say satellite connectivity, we're actually putting a base station on a space station. So it's a space station and it is a satellite, okay? So now the coverage and the footprint has tremendously changed. So that's what the rules were. Okay, so now the 3GPP continues to do the work in future releases to advance the work or the satellite, the standardization for the NTN, in particular for the D2D. And the same standardization work is also going on in ITU. The key aspect of this, why are we doing this standardization? The reason, one of the key reason for this standardization is so that we are not working as two independent networks. We have a terrestrial network. It covers a wide, a very large population, but where we have the satellite connectivity for the supplemental coverage, the two networks talk and there is a seamless connectivity. If you have the seamless connectivity, then you have the service continuity and all your user experience and everything comes into play. So that's ITU work, the WRC agenda, as well as the 3GPP work has really set us for direct-to-device issue on two tracks. One, using the mobile spectrum, which is already assigned, licensed, authorized to the mobile network operators. And I'm very glad to see at least we have one operator here, and who can talk about the use of their spectrum. And I already heard the word that the satellite connectivity was imperative. So that's good to, for the audience here. So this put us on two tracks to think about D2D. One using the mobile spectrum and one using, as I said, the spectrum which is already available internationally for mobile satellite services. So we are on two tracks, D2D in mobile spectrum and D2D in MSS spectrum, the spectrum mobile satellite service. So as I said, the agenda item was very clear that if you're using the mobile spectrum, well, you are providing supplemental coverage, you are making direct connectivity to unmodified phones, and you're not going to impact the mobile service, the terrestrial service. That's one of the conditions. So that's the international framework. Those are the principles we are working on right now as we are preparing for WRC 27. Those are the principles for the international framework. When I say you are not going to be impacting, if you look at the slides, that just means you're not going to be causing them interference. Their use is protected. If one operator is using their frequencies on a satellite, they will just have to make sure that another operator might be using the same frequency in the nearby area, it's not impacted. But it's a lot more than that. It's not just a national issue, it's got to have the cross-border issue. And I'm sure India understands very well how the cross-border issues work here. So we need the rules. Nationally, the regulators can manage, DOT can manage, or they can set the rules. But we need the rules how, when a space station is going to be using the base station frequencies up there, and by the way, that's the other thing I should have said in this D2D, most of the connectivity at this point in time in the mobile spectrum is non-geo constellations, which is we are talking about 400 kilometers to a couple of thousand kilometers. SpaceX is even below 400 kilometers. But anyway, we are 3 or 4 systems which are out there. That's the space we are talking about, these mega constellations, but low orbit. But that's not to say that the D2D is not happening from geostationary satellites. But that's mostly happening in the MSS bands. So we have an interference issue to make sure that one mobile operator's use of satellite connectivity does not interfere with another mobile operators nationally as well as internationally. And so some cross-border limits will be required. And then the standard handsets can be used. When we are using the satellite spectrum, well, again, I'm not trying to do a direct comparison, but there are pros and cons. We have the satellite spectrum. Don't need to go to WRC 27 and wait for any, regulatory change. For the satellite spectrum, we have it in 1 gigahertz to 3 gigahertz range, no problem, okay? But most of the systems at this point in time are geostationary. And you would think that my mobile, which is, transmitting at maximum 23 dBm or something, and making a link with geo. Yes, the satellite protocols are now connecting with the geo, and you might have heard of the Skylo service, and if you haven't, you should go to the IMC exhibit hall and you will find a demo of the Skylo service. I'm not advertising them, I'm just saying they are connecting to the geo satellites mobile handsets. So there are advantages, the regulations are set. But the handsets, this wasn't planned before, the handsets, just like Global Star iPhone service, iPhone had to have those Global Star bands, a new chipset. The same thing applies to all the other MSS bands. The mobile phones will need new chipsets to get the mobile satellite bands in there. And I mentioned that WRC 27 has a number of agenda items for mobile satellite. Well, they don't have just the D2D item. Mobile satellite industry is also asking for more spectrum. And where would you find that spectrum? Because 1 to 3 gigahertz is still sweet spot for spectrum for mobile satellite. So it's going to be in the 1 to 3 gigahertz range. So one of the thinking is that if they're going to be using another new bands in 1 to 3 gigahertz range, the most likelihood the bands are on the agenda are the bands which are already used for terrestrial mobile. They're used for MNOs, they're used for providing this, over 90% of the coverage we talk about. Well, those bands are used, they're used extensively. So we want to make sure that those bands are not affected negatively from interference. I should go on, 1 more minute, yeah. Okay, so I talked about the national regulations moving on D2D. And well, the print is not too bad. When I was reading on my slides, it was pretty small. I've given you at least 2 countries, geographically large, and these are their national regulations. And it's really worth recognizing, and the reason I'm presenting this is because I'm pretty sure that, with the importance of the D2D in India, that the regulator here is looking at making regulations for enabling the D2D, given that Vodafone is connected, has partnership with AST, and there are other satellite partnerships in the fixed network on the fixed side with SpaceX from Geo and Airtel. So from that perspective, it's really worth looking at what the national regulations are now, notwithstanding that the international framework will come in 2027. And the key aspects are, and one thing I've not covered, and that I've covered indirectly, D2D is going to use the mobile spectrum which is authorized to the mobile operators. It's licensed to the mobile operators. They have their conditions. D2D is going to provide service to the mobile terminals. They are also authorized under that license. Okay? So from that perspective, a satellite operator providing that satellite connectivity in a given country has to make sure that there is an agreement between the mobile network operator and the satellite network operator. Without such agreement, that can't work. So most of the regulators have, required the agreement. That's one of the conditions. And then, because there is no allocation right now for mobile satellite service, in our ITU parlance, we call it secondary service. So at this point in time, they are saying D2D can happen, and it's happening in US. It's the T-Mobile, SpaceX are providing the service as of last July. So commercially, it's available now. So the service is happening, but it is on no interference, no protection basis. So they have to protect themselves, and they can't cause interference to anybody. I'm done. So that's the handshaking. I just want to show, indicate that satellite industry is not new to the mobile industry. Mobile industry has been working with the satellite industry for a long, long time, doing backhauls, and now, so it should facilitate the development of all the partner agreements. They have to make MNOs with MNOs and SNOs. So they are making all these agreements right now, and there are a lot of statistics available. If you look at some of the GSMA reports, that the number of agreements available, and particularly the number of partnerships in this part of the world, in the Asia Pacific, is very, very large. Okay. And I think I will conclude by saying that the coexistence of the satellite services with the mobile is extremely, is essential. And now what does it do with the 6G side? As I said, the standardization will continue. The standards have been done so far for 5G NR, narrowband IoT from the satellite connectivity perspective. With respect to 6G, the future releases of 6G, which will come for the terrestrial standards, release 19, 20, 21 particularly. So those releases have an integral part of NTN as for development. And it's not just NTN satellite connectivity. You heard about other NTN solutions such as high altitude platform systems, etc. Those will all be part of the standardization in 3GPP as well as in ITU forum. I thank you very much for your attention.
Thank you, Veena. So I wanted to start with that backdrop because collaboration is key, but spectrum is a key enabler. I'd now like to move a little bit more towards the market side for NTN and D2D, and then move on to a little bit of technology, if I may. Let me just start on my left. Can you talk a little bit about the defense industry and how the defense industry may have been using satellites to date? Because if coverage is important, I think it will be important to the defense industry as well. So can you give us a bit more background about how defense uses satellite, how maybe it could be a complement through the NTN world?
Yeah, thanks for this. See, defense basically, as been explained earlier, coverage gap area is what affects us mostly. Okay. In any interland, in any countries, will covered with all networks. But as we go to defense utilization into the borders, there is a coverage gap. Then there is also a problem of sharing the same spectrum with the neighboring country when we are fighting with him. So that's a reality today. When I'm using a satellite-based connectivity, if I have to share with my adversary and still fight him, how do I resolve it is another problem that needs to be solved. Leave out all this. What main problem with defense is that between carrying a mobile handset and a bullet, soldier always prefers to carry the bullet first. Then he will talk about others' equipment later on, because he has to survive in the battlefield. So what we found is that with our experience, so I just requested my team to bring this form factor, this seems to be the best suited for them. Weight around 250 grams or so. And then more than this, anything more than this, it becomes cumbersome for a soldier. So this is what, whatever we do, whatever technology we want to bring, has to be compressed to this level. It will be very, very good for him if we put it into this level, but he can't hold it in while fighting, he can't hold this type of thing. So some with certain amount of gripping and hardening and all is what we're talking about, but not beyond this. So that's where defense requirement comes into. For example, Indian Army also has given out a big wish list, I should say, though they've given it as a request for information, but it's a wish list where they included everything. Main thing they included is that backward compatibility with existing press-to-talk equipment. That's very archaic equipment, Second World War equipment, but still most of them under use in the army. So we have to integrate that also. So when I say defense perspective, these are certain things that need to be taken into consideration.
I think also it's fair to say that the military prefer lower cost as well. So that may mean international standards, that may mean sharing costs of R&D across many countries as well. Clearly India is a big country, but the mobile industry tends to be a global industry.
Basically cost per se may not be a determining factor. It can be any cost. If it's required for military for sustaining, it's required, first thing. But while doing so, as you said, we have to rely on what is existing technology to deliver it to people. Like mobile technology today, mobile phones are getting manufactured in India. We would like to make use of the same base to extend it to the defense forces. That way, customization is lesser, cost is also lesser.
That's great to hear. So there are good cost considerations there. Can I move to you from a Bharti Airtel point of view? Clearly, coverage is an important driver for what you do today, and it's probable that you complement Wi-Fi services as well as cellular services in some locations today. How do you see the coverage drivers from a mobile operator point of view? Are they exactly as Venus said, or would you add some differences?
I think, again, eventually what will pan out is market dynamics, right? But if you had to look at the problems that we have to solve today, right? For example, last couple of months there's been a lot of rain in some of our northern districts. And I think what happens is sometimes we lose backhaul connectivity, right? You know, having a satellite link actually gives you not just an ability to cover a place where you have a coverage gap, but it's also an ability to kind of restore links where you actually broken down, even if it's a backup link, right? So this is my personal view, but eventually time will tell. I think from a pure operator perspective, how do we kind of create resilience and increase our coverage using something like an NTN network is what I would assume that we focus on initially. Eventually it starts to democratize back into commercial devices, and I agree with what Veena said, but I also agree with what you said. And standards then start to become important because, you know, for market dynamics to come in and things to start becoming democratized, as you said, the cost of R&D has to be amortized. And this is only going to happen when, you know, there is standards-driven stuff happening, people kind of doing multiple things, and, you know, there's a chance for companies to compete in that. Otherwise, you have a great technology solution, but then it becomes a very niche use case.
So can we talk a little bit about timing? We've heard a little bit about the standards from a release number point of view. How soon do you see the cellular satellite complements being more active in an Indian market? Can you do some predictions like that, or is that too difficult
I would have to hallucinate, I'll be very honest. I would actually look to you folks to actually tell me that, because, okay, I used to work on standards a while back, but here's the reality of the matter. These things can be tricky. I mean, especially if you look at regulation for some of the problems that you were speaking about. It's just not regulation within, you know, the regulatory framework here is slightly complex, I would suppose, because the things that you have to take care of are a bit more complex than pure terrestrial networks. So that takes time to settle. Standards kind of settle because, you know, people have views of how you want to do it. But then once the standards get into place, commercialization of that standard is also, it takes its time. So at this point, I'm not sure I would be able to take a guess at when you would start to see these things proliferating here. But that's really because I don't have a view into this at this point.
No, but I ask it partly because I think we're going to see more of NTN designed into 6G, but we are likely to see lots of experiments around the world between now and 2030, for example.
Absolutely. And I would, you know, sorry, I was kind of alluding more to commercial, I mean, handheld devices, but in terms of POCs and experiments, yes, I think when there's a bunch of stuff you're hearing around the corner, but I wouldn't be surprised the next couple of years you would start to see a lot of things popping up.
Can I also just highlight another market factor which I think is relevant and has not fully been covered? You have some of the most cost-effective mobile services here in India in the world. You know, your costs are really low compared to many countries. But the satellite prices, I think, are not necessarily as low as that. How can you think about bridging the pricing gap, you know, given the different cost profiles of cellular and satellite? I guess that's something to be worked through in time as well.
This is something, as you said, we'll have to work through, but this is two places where things start to kick in. Right now, you know, I was reading up something before I came here about how the cost of launching a satellite had actually come down. But the fact is, it still takes money, right? And while there is the cost of the actual logistics part of getting things in, again, to my view, it kind of comes back to what kind of standards we agree on, how we amortize things, right? And then how scale kicks in. Eventually in India, if you look at the reason we are able to do things at a particular price point is because of the scale that we are able to offer. And this is really the kicker.
Well, I think if we introduce satellite, it won't start at the same scale as cellular is here in India. It will take time, whether it's regulatory time, standardization time, delivery to the market time. I'd now like to go on to a few more technical questions, and maybe I could go first of all to Rahim, if you don't mind, and then come back to you. Rahim, clearly you've been involved with satellite for many years as well as cellular developments. Can you describe some of the integration challenges between cellular and satellite, and also some of the things you're working on in the near term?
Sure. No, thanks, Mike. First of all, I would like to get some of the terminology correct. First, when we talk about 6G, it's no longer only terrestrial. So when we talk about 6G architecture, it is three-dimension network of networks architecture, which includes satellites. I think sometimes, even for the last 24 hours in the meetings and etc., people say mobile and satellite. No, and in the context of 6G. When we talk 6G, it is unified architecture between the two segments. Yeah. And unified architecture, this term is important, unified, because in 5G, satellite and terrestrial was mainly interworking between each other. Satellite has its own proprietary technical solutions, and 5G has its own. 5G advanced, it is more integration. So interworking, integration. In 6G, it is unified architecture. So from a user's perspective, whether you are under satellite coverage or terrestrial coverage, using the same phone is seamless. So that is the sort of terminology we need to get when we are now we are having the two sectors of the space and the terrestrial industry. They're working with each other. We need to make sure that we get the terminology right. I agree with Vina about if we use mobile bands for the satellite, there is lots of complication, technical challenges, frequency coordination, and etc. Why don't we allocate a specific frequency band to satellite? Not to share it with the terrestrial system because of the complication, and having the same technical standards, air interface, and network protocols common between terrestrial and satellite. The only thing is different is just the RF frequency. And adding another RF band to handset is much easier than adding another chipset to the handset. And if we do that, the question that Mike said, the cost of the satellite is being more expensive traditionally compared to the terrestrial system. Yes, is the case because satellite always use proprietary standard. But this proprietary standard is not a global standard. The system becomes expensive because the supplier are only a limited number of companies can provide that. So when with the convergence between or unification between space and the terrestrial in 6G era, I'm sure the cost will be comparable with the terrestrial systems. Technical challenges, I already mentioned if we have a separate spectrum like MSS spectrum or L-band, S-band for the satellite, direct to device or direct to handheld, which is more challenging, then you solve most of these problems, as well as regulatory issues and etc. Other challenges are the one good thing about 5G enabled network slicing. One slice could be developed only for satellite. Why can't it be just, and this is deep level of integration and unification between the space and the terrestrial systems. And a slice is not only just for different service, it could be different networks. It could be satellite, it could be non-3GP, it could be Wi-Fi. But using the same architecture to control, to manage all of the sector. The most important challenge, technical challenge, is
not direct to device, which could be a vehicle for Internet of Things. You can afford a large phase array antenna on top of the vehicles, but it's direct to handheld. And there is a difference between direct to device and direct to handheld. Handheld, which is the same one as you mentioned, without too much modification of the terrestrial systems. And the major technical challenge is the uplink. Uplink to the satellite, because it's power limited. So for this, we need a new antenna design, phase array antenna design for the satellite. We need new flexible air interface to do adaptive modulation and coding techniques. We need new solutions for power amplifier, wideband amplifier on board the satellite, as well as a combination of all of this in order to achieve this. One idea that we proposed, we call it a space MIMO. When we have a mega constellation satellites, you have hundreds of satellites. At the moment, most of them, they operate individually, controlled by the gateway. We have the similar concept of cell-free architecture, which is a distributed MIMO. Why can't we use all this constellation and all the satellites to cooperate with each other in a form of a distributed MIMO in space? Of course, there are technical challenges like time, frequency, synchronization, and coordination, which is less of a challenge than doing everything through one satellite with limited power, limited bandwidth.
Rahim, we're going to need to move on a bit.
Okay.
So
There is many research challenges which I could list, but because of the time, I would say there are so many satellite systems coming up. You see Eutelsat, OneWeb, I've listened to Rivada networks, Telesat, and etc. How do you manage interference between all of these systems? Are they going to be sustainable? And interference between satellite systems itself is a big challenging research challenges. When we talk about direct to handheld, we are not talking about unification between 6G and space. We are not talking about SMS or voice services. We are talking about mobile broadband, the same data rate as you get on the terrestrial, you get it on the satellite. That is the biggest technical challenge to provide using the power limited and bandwidth limited satellite system. So I can expand on all of this if Mike allows me to talk again.
Well, you've come back, but I think, first of all, you made a comment about spectrum that I think Veena should respond to in relation to integration versus interworking. Do you want to comment briefly on that, Veena?
I think the comment was why, because there are so many complications in dealing with mobile spectrum, why not just have more spectrum for mobile satellite? Spectrum, this, as I said, the beachfront property for these services is for terrestrial, as we say, is up to mid-band, 7 to 10 gig, up to there. And the beachfront property for mobile satellite has been between 1 to 3 gigahertz. While that spectrum is not only used by mobile satellite, but is also, as I mentioned, used extensively. If you look at the use in India, every band from, I would say, 800 megahertz to 3 gigahertz, say 2.5 gig, is used. Thousands, millions of subscribers on it. So it's to reallocate it to the satellite service, no. I like your research idea about having one slice for satellite, one slice for that. The complexity of that, of course, you are going to be figuring it out from the university. But it's easy to say, why can't we just allocate it? Spectrum is at premium. And one thing I did not mention, I must mention, the spectrum which the mobile folks are using, when I say extensive use, they have paid billions of dollars for it, billions of rupees for it. It is not free. The satellite spectrum operates very, very differently. When you talk about the satellite spectrum sharing, yes, they share. They share the same spectrum. They differentiate between the orbits, etc. The sharing happens. And their fee structure from a regulator perspective is very different. They don't have to pay upfront this kind of money for the auctions to buy spectrum for commercial mobile service. You know, so that's a big difference.
So we're not going to resolve all that today, but I'd just like to give you a chance to speak to your slides. Mr. Krishna, do you want to go to the podium? Yeah. So CDOT have got some interesting slides just to show about technological developments, which I'd like to just put up on the screen.
Hey, so I thought I'll start with some fun stuff. If you might review your Physics 1 course from undergrad. But, you know, momentum is P, let's call it P equals mv. Then, you know, if you look at dr by dt cross P, then that's P is mv, right? So then you get v cross mv, so mv, so that becomes 0 because the cross product of a vector with itself is 0. And then force, a gravitational force is radially inward, so it's proportional to the radial direction. So that's kr in that direction. So now, but you know, Newton's second law, force is rate of change of momentum. So r cross dp by dt is again k into r cross r is also 0. So when if you define something called angular momentum, L, is r cross p, then the rate of dl by dt has these two factors, r cross dp by dt and dr by dt cross p, both are 0. So what that means is angular momentum as a vector does not change once a satellite is set into orbit. It is, and r, since L is r cross p, r is in a plane perpendicular to the angular momentum. So once you set it going in an ellipse, it stays there. But there are, next slide please. So, you know, normally LEO, MEO orbits here and all, we talk about circular orbits in the equatorial plane and stuff like that, but you know, orbits at low levels, but circular orbits around the Earth. And the dwell times are very short. So instead of the circle, why don't we stretch the circle further up? Then it starts serving a particular region better. So what we want to encourage countries to do is to start thinking about such elliptic orbits. So, and then you can set it into an ellipse. Like when you go down at the bottom, you can, let's say you start at a low circular orbit, you can give a cranking propulsion maneuver that will change its direction, and then it now picks up speed, and then starts going in an ellipse. And then and you leave it there. And then that ellipse stays there. There are some perturbations, but you know, you burn fuel to actually keep it in its plane. So, for example, here you have 4 satellites, and as the Earth rotates, each one comes up to serve a particular region. So we call this quasi-geostationary. So because the number of slots on the equatorial plane are limited, we can actually incline this at 63.4, where perturbation is nullified, and then they serve a particular region. So when we talk about D2D, direct to device, a device will always find a signal at that point in the sky because one of these 4 satellites is always serving. So that becomes a control plane for service. And then, you know, we can have satellites at lower levels as well, low Earth orbits, medium Earth orbits, and at the higher level, the quasi-geostationary level. And you know, you can provide service with different bandwidths and lower latencies. Latency is a millisecond every 300 kilometers of height. And you know, we can, so we'll have differential latencies, differential bandwidths as well. And you know, hopefully, you know, people can deploy such configurations. It can be useful both for civilian use cases, defense use cases. Every country can be empowered to provide their own satellite service. So what we want to do is encourage people to think elliptic and set the ellipse where you want, And we actually created one configuration for India, then we rotated it, and it works for UK, it can work for France, it can work for Japan. So, so maybe we can all do this together. Thanks.
Dylan, before you leave the podium, can we just say, how would you like to take this concept forward? Does it need new collaborations? Does it need new research? What does it need by way of next steps? And what's the rough timing you would imagine in this area?
I think though, with regard to TN and TN integration, we have to start integrating, the communication module that integrates with the cellular networks as well, especially for handoff, so that we have seamless service. We shouldn't just launch and just do surveillance with satellites, but also integrate the module that actually communicates with the cellular network, so I can work with Airtel's network, for example. But but a whole ecosystem has to come together. Who will launch? Who will build the communication payload? And what configuration should we use for each country? We may have to tweak it for each country, but and I think with the UK, India, FNI, we can do something collaborative with the European Space Agency as well, and develop technology together. I think it's one entity cannot do this. And there should be global consensus to actually say, hey, this is a way to provide service. So,
I think if you want to take a seat, and we'll have a few more questions from the seats. So it seems to me that international collaboration in this area is vital, otherwise it's not going to work. Some collaboration is going to be needed on the regulatory front, whether it's for spectrum. Some collaboration is going to be needed on a national basis for some of the rules of the road, particularly for large countries like India. We're also going to need collaboration on a technical basis, not just the standards itself, but some of the developments there. So that it seems to me that this is a plea for collaboration where we need to work on certain things. But I think the good news is that there's some very clever people already working on this today. It's not as if it's just starting today. Some of this has already started in the standards community or in some of the fora that exists. And in fact, only this week, the European Space Agency announced a partnership with the Bharat 6G Alliance to work together between European Space Agency and Bharat 6G Alliance on areas of experimentation as well. I'd now like to just go into a slightly different phase of the panel, if I may, and come back to you from a Bharti Airtel and a coverage point of view, if I may. Do you see other things that can come from the space and satellite industry that would be helpful? The example I have in my mind are things like positioning, navigation and timing, maybe the ability to use Earth observation more carefully from a space point of view, maybe better access to information services where space can tell us about certain things on the Earth. Are there some other things that you would like to see from a Bharti Airtel point of view from space that would be useful to cover?
I must admit, you have me stumped for an answer. Yes, some of the points that you actually mentioned is what springs to thought. But in all fairness, I think the first problem that we need to solve is connectivity. And I think in a way that's a mission for the company. So that's what we focus on. But everything you said is, yeah, it does make sense. It's on the table.
I think there are additional demand drivers besides coverage. You know, they quickly follow. If you have more coverage, people will want more from that coverage, whether it's information or perhaps navigation in some cases. Can I look at that from a military point of view? Clearly, there may be some other military needs, and what we don't want to do is to find that we take a very civilian approach to it and ignore the military needs. Are there some other things that you need from space besides just the traditional pattern towards NTN as being described?
Yeah. Basically, one aspect that I want to cover, and when you covered that PNT part of it, is that we are experimenting with ability of putting positional information as part of the communication stack. Initially, we do it at 5G and 6G at terrestrial level, then extend it to the satellite level. Because as we go along 5G, 6G and all that, the positioning requirement becomes very stringent. For example, today we have to support 1 million devices in 1 square kilometer. That's a target of 5G in around release 16 or so. That means 1 square meter accuracy they need. Then as we go to 6G, it becomes 10 million. That means 10 centimeter accuracy one requires. Now when you go to 8G or so, D2D when you go, that is direct to the device when you go, the requirement of us positioning becomes more stringent. Also, extending it to the indoors also becomes important. Yeah, when you have a satellite coverage, generally we think about open areas, but now we think about putting it indoors. One of our Indian mobile operator is experimenting with combining Wi-Fi spectrum with 6G. It's 6G outside. When it comes inside, it becomes a same device access a Wi-Fi router also. So that type of things will be of much help to military when we think about fusing things. At the satellite side, what I think is that today we have dedicated satellites for communication, dedicated for PNT, dedicated for Earth observation. We would like these satellites to be put together. That means I launch one satellite, there's an Indian experiment with that, which will cover a large spectrum and different users. Today we have communication satellites from VHF to UHF to very high frequencies. One communication satellite is there. But we'd like to have different applications in the same satellite. Then the cost of a satellite will reduce when many services are being offered. I think these things are the take home from the public side to the defense side.
I also think that's a call for standards and some rules of the road, if I can put it that way, in the satellite world.
Yeah. See, in terms of standards, we are working with, we have Telecom Standards Definition Society of India. We are working with them to get these standards to the communication stack. Then same thing will get extended further.
So I'm conscious we're against time, so quick response from you, and then I'm going to ask a wrap-up question.
Excellent question you are asking in terms of PNT. There is a big regulatory issue around the PNT part, and particularly for direct-to-device, because up until now, we are only communicating with the terrestrial systems, base stations, but now, as I said, we have Earth stations, because the satellite terminals are called Earth stations in our pockets. And there are, from a regulatory perspective, there are many countries who are very concerned that if I do not give a market access to a particular satellite system, people are just going to go cross-border and pick up a terminal which has got the satellite capability, a smartphone with the satellite capability, and would not have the authorization to transmit in a given country. You can't transmit unless you have the authorization nationally. There will be illegal transmissions, and it has got a very direct connection with the security and the privacy side, because some of these illegal transmissions are intentional, and they are intentional for privacy and security side. So there are certain countries, and you can imagine, in the world who are saying, if you're going to do that, make sure that the satellite must have the capability. Doesn't matter what technology they use GPS or any other technology, doesn't matter. ITU or nobody nationally should not dictate the technology, but must have the capability of knowing the position of the terminal you are communicating with. And if that subscriber is not authorized, you can't do that. In D2D, it should work, because these are mobile system subscribers, right? So the network, they do a lot of handshake, authentication, identification, registration, all that process goes on with D2D in a mobile terrestrial system. But in a regular MSS system, that does not necessarily take place. So PNT is extremely important issue from a regulatory perspective. Thank you.
So I'm glad we've included that. I'm now going to finish the panel with a final wish, if I may. So I'm going to suggest that I'm going to give you each a Diwali wish, and I'd like you to think how you're going to use the Diwali wish. So can you think ahead to India Mobile Congress 2026, the 10th edition next October, and tell me what will improve the progress of mobile satellite convergence in the next year? Could you go first on my far left, please?
Yeah, sure. I think if we have actual service and at least deployed as a proof of concept with handoffs happening between terrestrial and non-terrestrial, that will be
something of a prototype running, right? If you're able to, we've seen
So
the
demonstrators, do you mean?
Demonstrators are important because that picks up interest, that starts to drive the ecosystem.
Yeah, from my side, two are likely to be done before.
Two wishes?
Yeah, two will come up, is my idea. First is a demonstration of a D2D type of communication, which some of my friends in the industry are already trying to do using Indian geostationary satellites, because that would fructify. Next is standards. How do we get that PNT into the communication stack might fructify before next thing. Again, it's a wish list. So that's what.
For me also two issues, because I don't think Mike knows there are two Diwalis, Choti Diwali and Badi Diwali. Okay. So my wishes have got no level, but there are two Diwalis. So my first wish is that I hope that the connecting the unconnected happens a lot more. As I said, 50% of the population have got mobile phones, but they do not have internet access. So my first wish is to really improve that gap and have more population, for whatever reasons, have the handsets with smarter phones and digital skills. My second wish is obviously to say that hopefully India will have D2D trials and a commercial service available in next Diwali or the one after.
Thank you. Rahim?
Well, I think it's all good wishes, and I think it's probably longer time, but for me, the shorter time scale wish is we are working between Germany, Airbus, and UK, supported by ESA. There's a project called 6G Lino. And my wish is, we are designing a satellite. We are designing a satellite to be launched the first quarter or second quarter of next year, 2026, to do in-orbit testing of the satellite, 6G technology, the satellite. And my wish is it happens the first quarter, not the second quarter. That's it. Very simple wish I have.
Thank you very much. So thank you everybody for your wishes. Sorry, gentlemen over there, unless I can get a microphone to you, you won't be heard. So I think we'd better finish if you don't mind. I think we've heard a strong plea for collaboration, and I think that means not just national collaboration, but international collaboration. So I think I'm going to add a little wish to Bharat 6G Alliance to maintain the momentum in this collaboration theme, because we need your help to make sure that the solutions are available to everybody. Indian designs would be great, Indian demonstrators would be great, but also some collaboration internationally to make sure it works in many countries and we get the devices we need, not just the smartphones of today, but maybe the smartphones and connected cars of the future, where satellite can play a role as part of NTN. So on that, can you please thank my panel for being with us all today and being so open? And if I may hand back to our chairman, and I'll go and take your question offline if you don't mind, sir. No, well, I think we need to, for time reasons, wrap up, so we'll come and see you afterwards if you don't mind.
Great stuff. I just wanted to check that there is terrestrial and there is satellite, but over a period of time, the satellite will become cheaper, right, as the technology progresses. So why can't we 100% move to satellite over a period of time? If the bandwidth is good, we can do AR, VR and all that. It shouldn't become a Kodak moment where we are trying to protect old technology and then the new technology is much better. So if it's a harsh reality, go to satellite, it's cheaper, it's better over a period of time, and close the issue. So what's the panel's views on that?
Do I have a volunteer who would like to answer the question? If not, my proposal is there are people working on it, and I would prefer to give you a private answer if you don't mind, sir. So if the microphone is still available, I'll take one more, but we do need to close. Fourth row, gently, if you raise your hand again, sir, and the microphone's coming to you. Thank you.
Question for Veena, you see. So
you didn't mention fixed satellite services, so the KU and Ka band is there in addition to mobile satellite spectrum. So my question is now, for the satellite spectrum using cellular, right? So there are two options. So for where there is no coverage, like T-Mobile has done, you can have a dedicated 10 megahertz of spectrum. But that disadvantage is you lose capacity, right? Cellular capacity. So what do you think? Shall we use the same spectrum for both satellite and cellular, or we should carve out a spectrum just for satellite, as T-Mobile has done?
There is carved out spectrum.
No, so T-Mobile has 1992.
T-Mobile, okay, so T-Mobile was in a very good place, so you know, okay? They had a national piece of spectrum. That was satellites, I didn't cover all these things, there are lots to talk. But they had a piece of spectrum, 5 plus 5 megahertz in 2 gigahertz range, available, they paid for it to the government and have available nationally. So their partnership with SpaceX is beautiful because SpaceX can use that spectrum nationally, okay? And nobody else is operating, so their national interference situation is solved. However, they do have a cross-border interference situation with Canada because that spectrum is not available nationally. Yeah. And when I talk about the national regulations, Australia also had a national ban. But in Canada, there is no national ban. So when Mike talks about the collaboration, and he mentioned the national collaboration, there will be national collaboration among the operators so that a satellite doesn't have to switch frequencies every beam it goes through, because only in this area, operator 1 has got frequency band F1 and then F2, etc. Okay, so, and you talked about the KU-K band. Yes, those are broadband fixed connectivity, as you know very well. And 3GPP is also working now in one of those releases to standardize that, and that will also facilitate the harmonization of the standards there, will also facilitate the broadband connectivity to fixed networks as well as the feeder link side of the mobile satellite service.
Yeah, okay. I agree with you. And the last thing is that with satellite services, direct to device, you can't have more than 3 to 10 megabits. That's it. You can't have broadband
100%,
services.
and that's why the D2D service is not replacing Airtel's network or terrestrial networks, okay? There's a bandwidth limitation, and my colleague, looking at all the challenges, I'm sure he's going to solve one of the big challenges with the satellites, even if they are 400 kilometers. The latency is still 20 to 40 milliseconds, okay? Forget about the GEO, we have 500 milliseconds. How are you going to do voice and video? Leave alone cloud computing and the defense services, critical missions where we have such large latencies.
So thank you very much, everybody. Thanks for being with us. The next panel is about to start. Can I hand back to our chairman for the handover?
Thank you so much for such an insightful session. Now I would like to request the moderator to present memento to all the speakers. Now I would request Mr. Rajesh Kumar Pathak, DG Bharat 6G Line, to present the memento to the moderator.